All right, today we're gonna pull back the curtain on some of math's coolest secrets. And I'm not talking about boring rules you have to memorize. Nope, these are visual shortcuts, pictures really, that once you see them, I promise you'll never forget them. So let's just dive right in. I want you to think back to algebra class for a second. You probably remember a sea of x's and y's, right? Just abstract rules, so many equations. But what if I told you the key to unlocking some of the most famous formulas wasn't about the letters at all? What if it was all about pictures?
Okay, first up, we're gonna tackle a classic, the square of a sum. But forget memorizing stuff. We're not doing that today. We're gonna build this thing from the ground up, piece by piece. You'll see.
So let's start with a simple square. Imagine each side has a length of, say, a plus b. Now, you know the area of a square is just the side times itself, or side squared. So the total area here, it's just a plus b squared. Easy enough, right? This whole area is basically the answer we're trying to figure out.
Okay, now for the fun part. We're going to take that side, that a plus b, and we're going to split it into its two little pieces. We'll have one chunk that's length a and another chunk that's length b. And we're going to do that on the top and on the side of the square.
And look what happens when we draw those lines. All of a sudden, our one big square is made up of four smaller parts. See that? We've got a little square up here that's a by a, so its area is a squared. We've got a bigger square down here that's b by b, so b squared. And then what's left? Two identical rectangles. And each of those is a wide and b tall, so their area is a times b. So, think about it. The area of the whole big square, a plus b squared, has to be the same as all its little pieces added together. What do we have? We have an a squared piece, a b squared piece, and two of those AB rectangles. And just like that, there's the formula. A plus b squared equals a squared plus 2ab plus b squared. The picture tells the whole story. No memorizing needed. All right, that was addition. Pretty cool, right? Now let's see if we can do the same thing with subtraction. This next one is a visual puzzle called the difference of squares. And it's all about moving some shapes around to find a secret.
Okay, for this one we're starting with a big square. Its side is a, so the whole area is a squared. Now imagine we take some scissors and snip out a smaller square from the corner. This little square has a side of b, so its area is b squared. What are we left with? This kind of funky L shape. And its area? Well, it's just the big square minus the little one we cut out. A squared minus b squared.
But that L shape is kind of weird, right? It's not easy to work with, but check this out. With just one smart cut, right about here, we can split it into two much simpler rectangles. Now, watch carefully. We're gonna take that smaller rectangle we just sliced off, and we're just gonna slide it over and park it right next to the bigger one. And boom, just like that, our weird L shape has magically turned into one perfect, simple rectangle. And remember, we didn't add or remove anything, so the total area is still exactly the same. We just rearranged the puzzle. So, what are the sides of this new rectangle we just made? Let's look. The long side is the original A length plus that little B section we moved over, so its total length is A plus B. And the shorter side? Well, that was the original A length, but we chopped off the B part, right? So its length is A minus B. And here's the punchline. Since the area never ever changed, the area of that L shape we started with, a squared minus b squared, has to be exactly the same as the area of our brand new rectangle. And the area of the rectangle is just its sides multiplied together, a minus b times a plus b. There it is, our second formula, proven with a picture.
Now, you might be thinking, okay, that's a cool trick. But what if I told you this isn't a modern trick at all? This way of seeing math is ancient. Seriously, let's take a quick trip back in time and then see how these old ideas can give you a kind of mental math superpower today.
This is wild. This is a quote from Euclid from around 300 BC. That's over 2,000 years ago. And listen to how he describes it. The square on the whole line is equal to the squares on the segments together with twice the rectangle. It's exactly what we just drew. He wasn't using A and B, he was talking about lines and shapes. He saw the pictures just like we did. And get this, some historians think these ideas go back even further, maybe 4,000 years. But okay, this isn't just a history class. Who cares how old it is, right? The real question is, how can a 4,000-year-old idea actually help you, like today, in the real world?
Let's try something. Try to calculate 112 squared in your head. Sounds hard, right? But wait, let's use our picture. 112 is just 100 plus 12, so we're trying to find 100 plus 12 squared. That's our formula. A is 100 and B is 12. So what are the pieces of our square? Well, we have A squared, which is 100 times 100, that's 10,000. We have B squared, which is 12 times 12, 144. And we have those two rectangles, which are 2 times A times B. So 2 times 100 times 12, that's 2,400. Now just add them up, 10,000 plus 2,400 plus 144. You get 12,544. You literally just did that big calculation in your head by picturing those four little shapes.
So we've seen the pictures and we've seen how powerful they are. Now let's talk about how this helps you really master this stuff. Because when you know why the formulas work, it's almost impossible to make the most common mistakes.
Okay, let's talk about the #1 most common mistake in all of algebra. Seriously, it's so tempting to look at a plus b squared and think it's just a squared plus b squared. But you know better now, don't you? You can literally see why that's wrong. Forgetting the 2ab in the middle, that's like throwing away those 2 green rectangles from our picture. You can't just do that, the picture proves it.
So let's wrap up what we've learned. This is your new mental toolkit. First, formulas aren't just rules, they're descriptions of shapes. Second, the square of a sum, that's just a big square built from 4 little parts. Third, the difference of squares. That's just a rearranged puzzle. And finally, when you see it this way, these ideas become amazing shortcuts that make hard math actually pretty simple.
All right, one last thing before we go. A little challenge for you. Look at these equations on the screen. They've all got mistakes in them. But don't just try to remember the rules. I want you to try and picture the shapes. Ask yourself, wait, where are the missing rectangles? Did they put the puzzle pieces together wrong? Now that you can see the pictures behind the code, can you spot the errors?